Hello, let's continue our Sudoku adventure with Dewey Decimal by Gene. So we have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have search 6. We have these arrows in the grid, like this one here, and the digit in the cell with an arrow indicates the number of steps to the 6 in the direction of that arrow. So if this was a 2, then we would count 1, 2, and there would be a 6 here. And if you notice, that would make this a 1, because we have to count 1 to it, and would make this a 4. So this one, the singular 6 would give us the 2, the 1, and the 4 here, just as an example. And in addition to that, we do have clones in the grid. Just this is a clone of this. So within these cages, digits in the same relative position are the same. So cells in the same relative position have the same digit, might be another way to put that. So if this is a 2, this has to also be a 2. If this is a 3, this has to also be a 3. They exactly match. 5 here, but it's a 5 there. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, with search 6, I'm tempted to start with the clones, but actually with search 6, there's limitations because the arrow has to see a 6. So for example, these two can only go up to 3. So these are 1, 2, 3 because they have to be pointing at a 6. This is also 1, 2, 3. So we actually immediately get a 1, 2, 3 triple here, making this a 4, 5, 6, which makes this a 4, 5, 6. Okay. These both point at a 6, meaning they are not 6. And they're also not 5. So these are from 1, 2, 3, 4. The reason they're not 5 is if this was a 5, right? That would go count 1, 2, 3, 4, 5. That would put a 6 here, which would then tell us there's a 6 off the grid. That's really no good. So these are from 1, 2, 3, 4 for that reason. This is actually from 1, 2, 3, 4 as well, because it's pointing at a 6 down here. Anything else to talk about? This one is 1, 2, 3, 4. I mean, it seems like 5 and 6 are somewhat limited. This can't be a 6. It's 1 through 5, I guess. Okay, so maybe I should color here. So we'll just give each of these cells a unique color. Actually, we do not know that this one isn't green or orange. Digits are allowed to repeat in the cages, so we'll color these 3 to start with. That means green's one of these 2, purple's one of these 2, orange. Not sure we get much out of this. It means these are also green, purple, orange. And these are green, purple, orange. Oh, so this has to be a repeat. Okay. Because of roping, right? The green, purple, and orange have to end up in this box. They end up here. So this is green or orange. We don't know which one, but it's green or orange for sure. So it is a repeat. I don't know what restrictions we know about this. I may have to think about how this search 6 is working. What do these two add? I think these two are going to add to a specific digit, probably 5. So think about it this way: if this is a 1, that puts the 6 here, and that forces this to be a 4. 1, 2, 3, 4. And so they add to 5, right? If this is a 2, that puts a 6 here, and now this is 3 away, so that's a 3. So they're always going to add to 5. We basically proved it because it's symmetric. So these two add to 5. 1, 4, or 2, 3. This is pointing at a 6, and this cannot be a 6. So this is 1 or 3 only. Putting a 6 in one of these two cells. Are we wondering about where 6 goes in this column, perhaps? Not sure. Well, okay, that means there's definitely a 6 in one of these two cells, because one of these is a 2, which is going to point at a 6 over here. So one of these two is a 6. That's not a great corner mark, but there's a 6 here and a 6 here. What do we do about that? I mean, it could just be both purples. It could be both of these. Oh, if the 6 is in one of these two, then this is a 1 or a 2, making this a 3 or a 4. Okay, it's going to point at the 6. This is a 1 or a 2. This is pointing at the 6 here. Slowly making progress. So we know none of these are 6, none of these are 6. Is that helpful? Any other search 6s looking at these? This is 1 or 3. Huh. Oh, we can't put a 6 behind this arrow. That doesn't make sense. The arrow's pointing at a 6 up here. So that places the 6 here. So green is not 6. For what it's worth. There's a 6. Ah, there is a 6 up here, but I don't know where it goes. 1, 2, 3, 4. I need a 5 in one of these two. Huh. Is this 6? Oh, this 6 is pointed at by this one. So this is a 3, which makes this 4, which means purple is 6. Okay. Perfect. And now so this is a 1. So this has to be the 2 to point at the 6, and this has to be a 1 now, because it's the only 1, 2, 3 left, and that puts a 6 here. So that makes this a 2, pointing at that 6. This is a 2, pointing at that 6. This is not a 2. All right, well, there can't be... The 6 is down here. Actually, the 6 is exactly here in the column. And so this has to be a 3 for that reason, because we can't put a 6 behind the 3. And so that places the 6 here. Okay, I think we're doing well. I need a 3 here. In general, this is 1, 3, 5. I don't know if I want to pencil that yet. This is 1, 4, 5. So I guess we know this is 1, 4, or 5, making this 1, 4, 5. Ah, and this can't be the 1 or the 4. Got it. So this whole box is 1, 4, 5, right? But this cell here is cloned here, and this can't be 1 or 4. So this has to be 5, making that have to be 5. So that's 4, and that's 1, making that 5. So we know that it is the green. Okay. I'm just going to leave the orange, because that's the only clone left that we have to worry about. Right, this is the 5, because it's a clone. After we fill the 5, then the colors can clear. We need 2 and 3. This 3 tells me that's 3 and 2. So that means orange is 4, and we don't need orange anymore. Perfect. Now it should just be pretty simple Sudoku. We need a 4 in this box. We need 1, 2, 3 down here. This is... we need a 2 in this column. That's even better. That's 2, that's 3. So this has to be the 5, and this has to be the 1. Placing the 3 and 1 in this box. Placing the 2 and 3 in this box. Placing the 1. We need 4 and 5. They go like this, and we're done. All right, neat puzzle, Gene. Yeah, I had to remember that, or rediscover that 6s can't be behind search 6 arrows, which is probably an important deduction. Maybe the first step would have been coloring every cell that can't be 6. I'm kind of curious what that would look like. I'm not going to clear the solution here, but just I'll make any cell green that couldn't be 6 right from the start. These can't, so none of the arrows can be 6, obviously, and behind the arrows you can't make a 6. Yeah, so immediately we get this 6. So if we were to just play this out, right, the reason this is the only place for 6 in the row is because this cell's on an arrow. Arrows can never be 6. This is behind an arrow. These two are on arrows, and this is behind this arrow. And so this ends up as 6. We'll make that purple. And so now we know the rest of this box and column isn't 6. So is there anything else from the start? Yeah, we know this isn't 6. I'm not sure we get more out of that. Oh, this can't be 6, I guess. Yeah, I mean, it's a start. We know these aren't, we know the 6 is one of these two, so these aren't 6. Yeah, none of these are 6, so this can't be 6. Yeah, the roping. Okay, so yeah, we're reduced to these cells being where the 6s have to go, which is quite limiting. Okay, cool. Anyway, just a little nice divergence there. Well, let me know how you did. If you enjoyed this, why not leave a like, subscribe, and a kind comment below.